Welcome to C Programming Lecture 3. In this lecture we will look into more about Printf Statements to display different quantities on the monitor and Scanf Statement to get input through keyboard. Recall the Hello World C program that displays a string on the monitor, which was provided in the Printf statement. Note that the string Hello World is enclosed within the double quotes in line 7. In this C program, Printf statement in line 7 directly takes the string without any specification. The string provided in the Printf statement is a programmer set quantity that cannot be changed by the users, as users typically provided only with the executable file. So, to develop user-friendly software, programming languages have features and statements that facilitates the users to interact with the software as and when required. Output of the executable file of this C program is shown at the bottom of the screen. Use of Printf statement with different types of specification can help to develop versatile software that could be more user-friendly. First, let us look into the %s specification meant for representing strings. In the C program, Printf statement in line 7 is provided with the string Hello World through the %s string specification. Here the Printf statement have two strings separated by a comma. First string contains the string specification %s that requires a string in the Printf statement to display on the monitor. After the comma, string Hello World is provided for the %s string spec. Output of the execution of the exe file of this C program remains the same as shown at the bottom of the screen. As the string to be displayed on the monitor using Printf statement is provided through a string spec, we have the flexibility to manage that string in the C program. We will look into that step by step by first starting with our next C program example written for integer numerical quantity specification. High-level computer programming languages were developed in such a way to calculate and manipulate different quantities through less resources, less pollution and more environmental friendly. Resources include memory, time, energy and cost. Consuming more power will heat up the system, that leads to noise pollution through cooling system and environmentally unfriendly. With the type and size of the numerical values, the resource requirement of the memory, speed of data communication, amount of power consumed and processing time of calculations can be quite different. So, in C programming language, numerical values are classified as integer, float, long integer and double float. As the first example, let us look into this C program that displays an integer value on the monitor. Integer specification is %d or %i. Compared to the Hello World C program, this C program has variation only in the quantities within the parenthesis of the Printf statement. In line 7, Printf statement, there are two quantities within the parenthesis that are separated by a comma. First quantity is a string that contains the integer specification %d. This specification in the Printf statement requires an integer value that will be displayed on the monitor. In C language, we can use either %d or %i for integer value specification. Second quantity within the parenthesis of the Printf statement is number 3, which is a decimal integer value. Note that the second quantity is not within the double quotes, otherwise it would become a string. This integer value will be used at the %d specification in the first string to display on the monitor. Note, the first string quantity has \n after the %d integer specification. This new line character is to move the command prompt control to the new line after displaying the integer. Output of the execution of the exe file of this C program is 3 as shown at the bottom of the screen. Check this C program to get more familiar with the usage of specifications in the Printf statement. In line 7, Printf statement, there are 3 quantities within the parenthesis that are separated by commas. First quantity in the printf statement is a string with two integer specifications %d and %i respectively. Second and third quantities in the printf statement are integers provided as per the required two integer specifications that will be displayed on the monitor. Note that there has to be as many quantities as the number of specifications in the first string that must be provided in the printf statement separated by commas. Type of the quantities provided must also match the type of the specifications written in the first string. Tab space character \t is added between the two integer specifications in the first string to get one tab spacing between the displayed two integers. New line character \n at the end of the first string is to move the command prompt control to the new line after displaying the second integer. Output of the execution of the exe file of this C program is 3 tab space 4 as shown at the bottom of the screen. Depending on the quantity type, different kinds of padding are also available with the specifications that can be utilized in the printf statement. In line 7, printf statement, there are two different kinds of padding that are used for the integer specification. First one is to fix the total number of digits for the display of an integer and padded with zeros in the front. %03d will use 3 digits format for the display of the integer, and if the integer provided has number of digits less than 3, then so many zeros will be displayed in front of the integer. For the %03d integer specification, single digit integer 3 has been provided. So, there is a difference of 2 digits between the specification and the provided integer. Hence, in the output display of the single digit integer 3, 2 zeros are padded in the front. If the difference between the number of digits in the specification and the provided integer is 0 or negative, no zeros will be padded. Second one is to fix the total number of digit spaces for the display of an integer and pad with spaces in the front. %3d will use 3 digit spaces format for the display of the integer, and if the integer provided has number of digits less than 3, then so many spaces will be displayed in front of the integer. For the %3d integer specification, single digit integer 4 has been provided. So, there is a difference of 2 digits between the specification and the provided integer. Hence, in the output display of the single digit integer 4, 2 spaces are padded in the front. If the difference between the number of digits in the specification and the provided integer is 0 or negative, no spaces will be padded. It is possible to display the sign of the number irrespective of whether it is positive or negative using %+d. In line 7, printf statement %+d is used for the second integer specification. You can see this becomes quite handy for the display of complex numbers. 4 is the second integer provided for the %+d specification. Hence, plus sign is displayed in front of the positive integer 4. ANSI C programming language does not have feature to handle complex number as a single quantity, so real and imaginary parts are to be dealt appropriately to perform correct calculations for complex quantities. In the printf statement, j, which represents square root of -1, is appropriately added in the first string for the proper display of a complex number. J is used in physics and electrical and electronics engineering. Instead of J, one can also use I for representing the imaginary quantity. Note that J has nothing to do with the integer specifications in the first string. If J is not added in the string, then it will not be displayed. %f specification is available for floating point decimal numbers. In the C program, printf statement has 4 %f float specifications. That takes 4 float numbers to be displayed separated by \t tab space specification. %f specification by default displays 6 decimal places. The float number provided for %f specification is 3.245. which has only 3 decimal places numbers. So, in the output 3 zeros are displayed to fill the %f specification, default display of 6 decimal places. Number of decimal places to be displayed can be specified in %f specification as point followed by so many places in between the % and f. For %.3f specification, 3 decimal places will be displayed. 3.245 has exactly 3 decimal places numbers. So, in the output provided float number 3.245 will be displayed as 3.245. For %.2f specification 2 decimal places will be displayed. 3.245 has 3 decimal places numbers and hence it will be rounded off to 2 decimal places. In 3.245, third decimal number is greater than or equal to 5, hence, 2 decimal places round off need second decimal place number 4 to be incremented by 1 as 5. So, in the output provided float number 3.245 will be displayed as 3.25 after 2 decimal places round off. For %.1f specification 1 decimal place will be displayed. 3.245 has 3 decimal places numbers and hence it will be rounded off to 1 decimal place. In 3.245, second decimal number is less than 5, hence, 1 decimal place round off will keep the first decimal place number 2 as 2 itself. So, in the output provided float number 3.245 will be displayed as 3.2 after 1 decimal place round off. %f specification has padding and sign revealing features as well. In the C program Printf Statement has 3% float specifications, with first and second separated by \t tab space specification and nothing between the second and third. %+f specification by default displays 6 decimal places and reveal the sign of the float's number irrespective of whether it is positive or negative. The float number provided for %+f specification is 3.245, which is the positive number and has only 3 decimal places numbers. So, in the output plus sign is revealed in front of the number and 3 zeros are displayed to fill the %f specification default display of 6 decimal places. %06.2f specification will display the number with 2 decimal places and pad so many zeros in the front of the number to fill the total characters as 6 including the decimal point. 3.245 has 3 decimal places numbers, so it will be rounded off to 2 decimal places number as 3.25. 3.25 has 2 decimal places, add 1 for the decimal point character and add 1 more for the unit quantity 3, totaling to 4. 6 minus 4 is 2 and hence, 2 zeros are padded in front of the number displayed as per %06.2f specification. %+8.3f specification will display the number with 3 decimal places, reveal the sign and pad so many blank spaces in the front of the number to fill the total characters as 8 including the decimal point and plus sign. 3.245 has 3 decimal places numbers, so it will be considered as such as 3.245. 3.245 has 3 decimal places. Add 1 for the decimal point character, add 1 for the plus sign and add 1 more for the unit quantity 3, totaling to 6. 8 minus 6 is 2 and hence, 2 blank spaces are padded in front of the number displayed as per %+8.3f specification. %C specification is available for keyboard ASCII characters. ASCII stands for American Standard Code for Information Interchange. In the C program, Printf Statement has 2% C character specifications that takes 2 characters to be displayed separated by nothing. In C programming language, character is enclosed within single quotes. %C specification is used for displaying characters. The character provided for %C specification is I. Characters must be enclosed within single quotes. So, in the output character I is displayed. %2c specification is used for displaying character with padding. The character provided for %2c specification is C. Single blank space will be padded before the character as per %2c specification. So, in the output blank space followed by character C is displayed. The space between characters I and C is because of the padding. Various types of variables can be declared and they can be used for storing, processing, and displaying different types of quantities. Using printf statement, values of the variables can be displayed on the monitor using appropriate specifications. In this C program, 3 different types of variables declared from line 7 to 9. ANSI standard is to declare all the necessary variables at the very beginning of the function. Some compilers might allow declaration of variables anywhere in the code, but it might become a non-portable C source code for other compilers or to compile in computers with other operating systems. So, keep it as a strict practice to declare all variables at the beginning of the function while developing C programs. In line 7, variable named A is declared as integer type. Keyword int is used in front of the variable name A to declare it as an integer type. All alphanumeric characters and special character underscore are allowed in coining variable names. Blank spaces are not allowed. In C and C++ programming languages, alphabet characters are case sensitive, so uppercase and lowercase of an alphabet can be used as 2 different variables in a program code. Reserved keywords like main, printf, int, void, return, and so on cannot be used as variable names. Declaring an integer variable will reserve 4 bytes of memory in the RAM dedicated to store the integer value of the variable A. As no value for the declared integer variable is input through the keyboard or assigned or initiated in this program, garbage value whatever was stored in the 4 bytes of RAM memory location will be the value for the variable A. Some compilers might initiate the value as 0 as soon as the variables are declared. As this is just an example C program about variables declarations, whatever the integer value of the variable A in its dedicated memory location is displayed as per the %I specification provided in the printf statement. Note that in the printf statement, variable name is provided as the integer to be displayed, so garbage integer value available at the RAM memory location reserved for variable A will be used as the integer value for display. 2 was displayed when the exe file was executed. This value can be different or changed if the exe file is executed again different times. In line 8, variable name B is declared as float type. Keyword float is used in front of the variable name B to declare it as a float type. Declaring a float variable will reserve 4 bytes of memory in the RAM dedicated to store the float value of the variable B. As no value for the declared float variable is input through the keyboard or assigned or initiated in the program, garbage value whatever was stored in the 4 bytes of RAM memory location will be the value for the variable B. Some compilers might initiate the value as 0 as soon as the variables are declared. As this is just an example C program about variables declarations, whatever the float value of the variable B is displayed as per the %.2f specification provided in the printf statement. Note that in the printf statement, variable name is provided as the float to be displayed, so garbage float value available at the RAM memory location reserved for variable B will be used as the float value for display. 0.00 was displayed when the exe file was executed. This value can be different or changed if the exe file is executed again at different times. In line 9, variable named C is declared as character type. Keyword char is used in front of the variable name C to declare it as a character type. Declaring a character variable will reserve 1 byte of memory in the RAM dedicated to store the ASCII character value of the variable C. As no value for the declared character variable is input through the keyboard or assigned or initiated in the program, garbage value whatever was stored in the 1 byte of RAM memory location will be the value for the variable C. Some compilers might initiate the value as blank space as soon as the variables are declared. As this is just an example C program about variables declarations, whatever the character value of the variable C is displayed as per the %C specification provided in the printf statement. Note that in the printf statement, variable name is provided as the character to be displayed, so garbage float value available at the RAM memory location reserved for variable C will be used as the character value for display. Blank space was displayed when the exe file was executed. This value can be different or changed if the exe file is executed again at different times. Values for the variables can be set or provided in few different ways. We will look into them one by one. In this C program, 3 different types of declared variables are assigned values through assignment statements from line 11 to 13. When the values are assigned to the variables, the garbage value at the respective variable's RAM memory content will be erased and stored with the assigned value. Assigned values of the variables can be used for further processes or to display them on the monitor using appropriate specifications provided in the printf statement. In this C program, 3 different types of declared variables are initiated with values in their respective declaration from line 7 to 9. When the values are initiated to the variables, first the requested RAM memory location content will be stored with the respective initiated value. Then the variables will be allocated with that respective initiated RAM memory address location. Thus, assigning value to variable is different from initiating them in their declaration statements. Initiated values of the variables can also be used for further processes or to display them on the monitor using appropriate specifications provided in the printf statement. In this C program using Scanf Statement, an integer value is received as input through the keyboard for the declared integer variable int1. In line 9, to develop the program as user-friendly and to inform the user that the further program execution needs an integer input through the keyboard, appropriate message is displayed on the monitor. Program control after displaying this message will wait for the user action for input through keyboard, as shown in the output at the bottom of this screen. In line 10, Scanf Statement, which is a formatted scan instruction that will receive value from the keyboard, as per the specification provided within the parenthesis. There are 2 quantities within the parenthesis in the Scanf statement, separated by a comma. First one, that is within the double quotes, is meant for the specification of the value that has to be input through the keyboard. Here %I specification is written for the integer value to be input through the keyboard. Don't use padding or point specification in the Scanf statement. It must be written simply as %I, %F, %C and so on. Second item in the parenthesis of Scanf statement is the memory address location of the integer variable int1. Memory address location of declared variable is accessible through the pointer of the variable, and it is written as ampersand followed by variable name. As the integer variable name is int1, the memory address location pointer is written as ampersand int1. When the user input the integer value in the command prompt and press enter, that input value will be stored at the memory address location of variable int1. Input values of the variables can then be used for further processes or to display them on the monitor using appropriate specifications provided in the printf statement. As per the printf statement in line 12, second line is displayed on the monitor as shown in the output at the bottom of the screen. In this C program using Scanf Statement, a float value and character value are received as inputs through the keyboard for the declared float variable f and character variable c. Specification %f is written to receive float value from the keyboard and store it in the memory location pointing to float variable f content. Note that %f is used as the pointer. Specification %c is written to receive character value from the keyboard and store it in the memory location pointing to character variable c content. Note that %c is used for the pointer. Output of the printf statement at line 10 is shown at the bottom of the screen, and it is waiting for the user to input a float and character value entered through keyboard. First, a float value should be entered followed by a space or tab space or enter. Then the character should be input and press enter. In the output shown at the bottom of the screen, the float value 4.5 is entered, followed by a space, and then character H is input and return key is pressed. 4.5 float value is stored in the 4 bytes of memory allocated to float variable f. H. Character value is stored in the 1 byte of memory allocated to character variable c. Thus, input values of the variables can then be used for further processes or to display them on the monitor using appropriate specifications provided in the printf statement. Outputs of the printf statements at line 13 and 14 are shown at the bottom of the screen as per the respective specification and variable name provided. All the C program's examples discussed in this lecture are provided as examples to learn about printf and scanf statements. Try to write C programs yourself to get more practice, experience and confidence in coding computer programs. In the next lecture, we will look into how arithmetic operators plus, minus, asterisk, slash and % are useful to write C programs that can solve simple scientific and engineering problems. In addition to these, we will also look into arrays. Next lecture provides introduction to one-dimensional arrays followed by two-dimensional arrays.